Every time you park a car, catch a ball, or fit a suitcase into a trunk, you are doing geometry. Your brain is quietly judging shapes, distances, and angles without a single formula. And yet somewhere in a classroom, geometry turned into a pile of symbols to memorize, and most people quietly decided it was not for them. Here is the truth they skipped. Geometry is not about formulas. It is the oldest, most practical math there is. It is simply the study of shape, size, and space, and it was invented to solve real problems. How do you measure a field you cannot pace out? How do you build a wall that stands straight? How do you find your way across an ocean? Geometry answered all of that long before it became a worksheet. So today we are going to rebuild geometry from the ground up, in the order it actually makes sense, so the shapes and the formulas finally connect to something real. I am Daniel, and this is Simplex Academy, where we take ideas that usually feel impossible and make them simple from the ground up. Let us start at the very beginning, with the pieces everything else is built from. Geometry is built out of 3 simple ingredients, and once you see them, every shape you will ever meet is just a combination of these. The first is a point. A point is nothing more than a position, a single spot in space. It has no width, no height, no size at all. It just marks where something is. The second is a line. If you take a point and let it travel perfectly straight, forever in both directions, you get a line. Straight, endless, and one-dimensional. And the third is a plane. Imagine a perfectly flat surface, like an endless tabletop, stretching out in every direction. That is a plane. Points sit on lines, lines sit on planes, and from these 3 quiet ideas, all of geometry grows. Now, the moment 2 lines meet, something new appears, and it is one of the most useful ideas in the entire subject. An angle? An angle is simply a measure of turn, how much you rotate from one direction to another. We measure that turn in degrees. Picture standing still and spinning all the way around until you face the same way again. That full turn is 360 degrees. Turn only halfway, so you are facing the exact opposite direction, and that is 180 degrees, which is why a straight line measures 180, and turn just a quarter of the way, a perfect corner like the edge of a book, and that is 90 degrees, the famous right angle. Anything less than 90 we call acute, a sharp little angle. Anything more than 90 we call obtuse, a wide open one. That is really all an angle is. Not a scary symbol, just an amount of turning. With points, lines, and angles, we can now build shapes, and shapes hide some beautiful rules. Take the humble triangle, 3 straight sides. Here is something that is true for every triangle you could ever draw, no matter how stretched or squished. Its 3 inside angles always add up to exactly 180 degrees. Always. A tall, thin triangle, a wide, flat one, it does not matter. So if 2 of its angles are 90 and 60, the third one has to be 30, because they must total 180. Geometry is full of quiet guarantees like this, and they are what make it so reliable. Shapes also carry a kind of hidden order called symmetry. A shape has symmetry when you can fold it, flip it, or turn it, and it still looks exactly the same as before. A square has plenty of it, a butterfly has it straight down the middle, and a circle has it in every direction at once. Symmetry is not just something pretty to look at. It is why buildings feel balanced, why a wheel rolls smoothly, and why nature keeps reusing the same efficient shapes over and over. Once you start noticing symmetry, geometry stops living on the page and starts showing up everywhere you look. Now, let us talk about measuring shapes, because this is where 2 ideas get mixed up constantly, and telling them apart will save you a lot of confusion. Perimeter and area. Perimeter is the distance all the way around the edge of a shape. Think of the fence around a garden. If a rectangle is 5 meters long and 3 meters wide, you walk 5, then 3, then 5, then 3 to get back to start, which adds up to a perimeter of 16 meters. Area is completely different. Area is the amount of flat space inside the shape. Think of the grass inside that fence. For a rectangle, you find it by multiplying the length by the width. 5 times 3 gives an area of 15. And notice the units. Perimeter is measured in plane meters, but area is measured in square meters because you are covering a 2-dimensional surface. That little difference, a line around versus a space inside, trips up more beginners than almost anything else. Once you understand a rectangle, other shapes fall into place. A triangle, it turns out, is just half of a rectangle. Picture any rectangle and slice it corner to corner. You get two identical triangles. So the area of a triangle is simply 1/2 times the base times the height. If the base is 6 and the height is 4, then 6 times 4 is 24, and half of that is 12. You did not memorize a random formula. You cut a rectangle in half, and this is the quiet trick behind measuring almost any flat shape at all. If a shape looks complicated, you can usually chop it into rectangles and triangles, find the area of each simple piece, and add them together. A 5-sided figure, an L-shaped room, an odd garden plot, all of them surrender to the same move. Break the hard shape into easy shapes you already understand. Geometry rewards that habit again and again, and it means you only ever need to truly master a few simple areas. Circles feel harder, but they run on one elegant idea. If you measure the distance around any circle and compare it to the distance straight across, that ratio is always the same number. A little over 3, about 3.14. We call that number pi. It never changes. For any circle, anywhere. Once you know pi, everything about circles opens up. The distance around, the circumference, is just pi times the distance across, and the area inside is pi times the radius multiplied by itself. For instance, a circle with a radius of 3 has a distance around of about 18.8 and a space inside of about 28.3, taking pi as roughly 3.14. The point is not to memorize those. The point is to see that a circle is not mysterious. It is governed by one constant relationship that humans noticed thousands of years ago. Let us take a quick breath because you have already covered the real foundation of geometry. Points, lines, and angles build shapes, perimeter measures around them, and area measures inside them. If this is finally making shapes feel simple instead of scary, that is exactly what this channel is built for. So consider subscribing to Simplex Academy. Hard topics explained from zero, without the fluff. Now let us step off the flat page and into 3 dimensions. So far everything has been flat, living on a plane. But the real world has depth, and geometry handles that with 2 more ideas that people constantly confuse. Surface area and volume. Imagine a cardboard box. The surface area is the total amount of cardboard it takes to cover the outside, all 6 faces added together. It is still a flat measurement, just wrapped around a solid. Volume is the amount of space the box actually holds inside, how much you could pour into it. For a simple box, you find the volume by multiplying length by width by height. A box that is 2 by 3 by 4 holds 2 times 3 times 4, which is 24. And just like before, watch the units. Volume is measured in cubic units because you are now filling 3 dimensions, not 2. Flat things get square units. Solid things get cubic units. And the same idea scales up to every solid, not just boxes. A can of soup is a cylinder, a ball is a sphere, and an ice cream cone is, well, a cone. Each one has its own way of counting the space inside, but the goal never changes. Surface area always asks how much it would take to wrap the outside, and volume always asks how much would fit inside. Once you hold on to that one difference, the specific formulas are just details you can always look up. Now I want to show you the single most famous rule in all of geometry, and I want you to actually understand it, not just recognize it. The Pythagorean theorem. It only works on right triangles, the ones with a perfect 90-degree corner, so keep that in mind. In a right triangle, the longest side, the one across from the right angle, is called the hypotenuse. The theorem says this: if you build a square on each of the 2 shorter sides and add their areas together, you get exactly the area of the square built on the longest side. In the usual shorthand, the first side squared plus the second side squared equals the longest side squared. Let us make it real with the most famous example. A triangle with sides 3, 4, and 5. 3 squared is 9. 4 squared is 16. Add them and you get 25. And 5 squared is also 25. It matches perfectly. That is not a coincidence. It is true for every right triangle, and it lets you find a missing distance you cannot measure directly. And here is where geometry quietly joins forces with algebra in something called the coordinate plane. Take 2 number lines and cross them, one running left and right, one running up and down. Now every point in that flat space has an address, A pair of numbers, how far across and how far up. We write it as an x value and a y value. Suppose you want the straight line distance from the center point at 0 and 0 to a point 3 across and 4 up. Look closely and you will see a right triangle hiding there, with legs of 3 and 4. So by the Pythagorean theorem, the straight distance is 5. Geometry and algebra, working as one. That single idea powers how your phone measures distance on a map. This same triangle thinking lets you measure things you could never reach with a ruler. Say you want the height of a tall tree. You cannot climb it with a tape measure, but you can stand back a known distance, measure the angle up to the top, and let a right triangle hand you the height. Surveyors have measured the heights of mountains this way for centuries, standing safely on the ground. That is the real magic of geometry. It quietly turns the things you can measure into answers about the things you cannot. There is one more pair of words worth clearing up, because they sound similar but mean different things. Congruent and similar. Two shapes are congruent when they are exactly the same shape and same size, like two copies of the same key. Two shapes are similar when they are the same shape but different sizes, like a photo and a scaled-up version of that same photo. Same proportions, different scale, their angles match, but their sides grow or shrink together. That idea of keeping the shape while changing the size is behind every map, every blueprint, and every time you resize an image on a screen. So, where does all of this actually show up? Everywhere you look. Builders and architects use angles and the Pythagorean theorem to make sure walls are straight and corners are square. Every map and every GPS route is coordinate geometry finding distances between points. The screen you are watching right now is a grid of tiny squares, pure geometry, and every video game builds its world out of shapes and coordinates. When you tile a floor, wrap a gift, or figure out if a couch will fit through a door, you are using area, volume, and space without calling it math. Geometry was never abstract. It is the invisible framework behind the built world. Before we wrap up, let me save you from the mistakes that trip up almost every beginner. First and most common, confusing perimeter and area. Perimeter is the distance around, area is the space inside, and they are never the same thing. Second, getting the units wrong. Flat area is always in square units, and solid volume is always in cubic units. If your answer for a space inside a box is not in cubic units, something went sideways. Third, using the Pythagorean theorem on a triangle that does not have a right angle. It only works when there is a perfect 90-degree corner. Fourth, mixing up congruent and similar. Congruent means identical. Similar means scaled. And fifth, the big one, memorizing formulas without ever picturing the shape. Every formula in geometry is just a shortcut for something you can see. If you can picture it, you rarely need to memorize it. So let us bring it home. Geometry is not a pile of random formulas. It is the study of shape, size, and space, built from three simple ideas: points, lines, and planes. From those, you get angles, which measure turning. From angles, you get shapes, which follow reliable rules. Like a triangle's angles always summing to 180. You measure the edge with perimeter, the flat inside with area, and the solid inside with volume. The Pythagorean theorem ties distances together on right triangles, the coordinate plane marries geometry to algebra, and congruent and similar describe when shapes match or simply scale. Underneath every formula is a picture, and once you can see the picture, geometry stops being a subject you survive and becomes a way of seeing the world. So tell me down in the comments, what part of geometry confused you the most back in school? And I might rebuild it from zero in a future video. And if this finally made geometry click for you, subscribe to Simplex Academy. I am Daniel, thanks for watching, and I will see you in the next one.